Welcome to another Teacher Tobin tutorial. Today I would like to continue to help math and science teachers introduce themselves to programming. We're going to use Python3, an iPad and the app Pythonista, and the topic today is the Fibonacci number sequence. It's a topic you probably already have covered in class, but we're going to take the logic and apply it to a programming paradigm, in this case Python3, and I'm going to walk you through the code for creating a Fibonacci output of about 10 numbers. I love the Fibonacci sequence. It's when I was a student, it provided the bridge between art and design, which I was interested in, and parts of the curriculum which I didn't understand so well, math and science. And it provided that link, and also history, of course, as well. The golden ratio, of course, being related to the Fibonacci number sequence. So it's hugely important. It's a really great way of introducing, in this case, problem solving. Sometimes teachers continually talk about problem solving, but this really is getting to the nitty-gritty of the subject. Because the concept of counting in Fibonacci numbers is pretty straightforward. We start with a 0 and a 1, and then we can add the preceding terms together, two preceding terms together, and we get the subsequent terms. So 0, 1 is 1, 1 plus 1 is 2, etc. That's pretty straightforward. But when you have to think about a programming language and how you can translate that logic, it's not so easy. So lots of great skills learned in this particular session. Okay, let's get started. Before going straight into programming, it's always best to look at the underlying logic, and there are two central concepts here that we need to cover. First is while loops and the other variables. So I'm going to use a quick analogy, that of a kettle and two mugs, one containing tea, one containing coffee. So a while loop is a bit like a boiling kettle. The water is not 100 degrees Celsius yet, so the electricity carries on to the immersion heater and it keeps on boiling until a condition is met. 100 degrees Celsius triggers the switch to turn off, and then it stops boiling because we don't want the water just to carry on boiling. That is essentially a while loop. A coffee cup might contain coffee, and a tea mug might contain tea. They are what we could call containers, or variables. Now, the amount of tea and the amount of coffee can change. So those two quick concepts I need you to understand while we're discussing the Fibonacci number sequence. So we'll get back to while loops in a moment, but let's first look at this problem and how we could present it to our students. So we've got this issue where we want to count in a particular way. So what I would suggest is tell your students to look at this number sequence and assign the first two numbers a letter, and what we'll call those a variable. A and B can change, and they will change for every pair of A and B numbers that you see. So the next time you count, A and B will have changed. And then present that problem to them and ask them to come up with solutions, maybe in small groups or individually, and then into small groups to discuss, and then present to the class as a table how they would approach that problem of updating A and B, and explain on the board. Because this is really the root of the programming language that we're getting to here. What we would like to do is update the values of these variables each time we have an iteration or loop. So you could think of pairs of numbers as a loop, and every time we count in pairs, we're actually going around again using a particular bit of logic to update the numbers. So here it is. If we say A equals A plus B and B equals A plus B, then I'll walk you through how this can update our numbers, our variables. So if we're looking at A, what we've said is that A equals A plus B. So 0 plus 1 is 1. Okay, so that's 1. And therefore our new value for A is 1. Now we have just updated our value of A. So if we looked at the value of B, the value of B is going to equal 1 because we've updated that value, plus B, which was defined as 1 before. It was defined as 1 because we had it here. So B is actually now 2. It's been updated to 2, which is why we have our 2 here. And that will work all across these number pairs. And what you're essentially doing here is updating a variable. So our variables might have started with A and B and 0 and 1, and now they're 1 and 2. They've been updated. So every single time we go through a loop, we can update the value. So how does that loop work? Well, let's have a little look here. So if this is our while loop within this circle, then what we're going to do every time we go for another round of counting is we're going to say, well, first of all, we're going to print, which is Python's way of saying write down what we had. Let's just print our A and B, and then we're going to say we're going to update the value of A and B. Next, we're going to update it. So these will update the variables, and then we'll just go around again, and we'll keep on looping around until a condition is met. Right now we don't have a condition, so these will just carry on forever. The while loop should have a condition. So what we want to say is, I mean, the most simple way of saying it, while we're counting from, let's say you count from 0, and we want to go up to, we want 10 numbers. So we need 2 more variables to use here. So what we can do is say, okay, well, let's have an initial count variable of 0, and let's have a max count variable of, say, 5. I'll tell you why 5 and not 10, because what we want to happen is under here we want to say count equals count plus 1. So every time we have a loop, we're updating how many times we've counted. So if we started with 0, then we've counted, we're going to update the count to 1, 2, 3, 4, and 5, because we've got 2 numbers every time we go for a loop. So we're outputting 2 numbers in pairs. So we don't need this max count to be 10. It can just be 5. So each loop we can update this variable to say, okay, we've counted, gone from 0, we've counted once, and we've counted twice, and we've counted 5 times. It's produced 10 numbers because we've got A and B's in pairs, and therefore we have our output of 10 Fibonacci numbers. So that hopefully this concept was clear, and you'll be able to see how this translates exactly to Python 3 syntax with our code. Alright, so in Pythonista, I'm going to use iCloud storage. I'm going to just name my new Python file. So I'm just going to name it, I never use spaces, and it should end in py for Python. So at the top of this, I'm probably going to define my variables first. That's normally what I try to do. And I'm going to define the starting values of A and B, 0 and 1. Our sort of first pair of numbers, if you like. Then I'm going to have update the counter to start with 0, then the max count. Make sure there are no spaces in your variable names, and then I'll probably give that a 5 because at each loop we're doing a pair of numbers, which means 5 loops, 2 numbers, 10 numbers. So at the top, I think what I'm going to do is just say to whoever's using this program what it's doing. I think it's always polite just to say this program, this program outputs the first 10 Fibonacci numbers. So I'll just put that at the very top. So I've defined my variables, add a little bit of instruction, and then while I'm going to open up a while loop, and then while the count is less than max count, 0, 1, 2, 3, 4, which will be 5 iterations, I'm going to have a while loop running. So as you have a colon at the end, when you press return after that, it will say, okay, everything we do now is within the while loop. So we have a little bit of code there saying count equals count plus 1, because I want to update the count variable value every time we go for a loop. So eventually it will count from 0, 1, 2, 3, 4, and as long as it's less than the max count, it will carry on running. When it hits the max count, it will stop running. So this is the variable updater for A and B. We worked through the logic in the previous example and explained everything, so you should be aware of where that's coming from now. But before we update our numbers, let's actually print out our values of A and B, current values of our A and B. And this little bit of code here, end equals, and then 2 speech marks, that allows the numbers to be written in one line. If you didn't have that, it would just go one number, a carriage return, and then underneath another number. So it would still work. It's just that's a nice little neat bit of code for keeping everything in one line. And that really is it. That is essentially the code. So what I would suggest as an extension to this project is, and I'll probably do a video for this, is to work out the golden ratio. Because if you've got a Fibonacci number sequence, then we could work out what the golden ratio is based on 2 Fibonacci terms. So here let me just update the max count to 10, and you can see you've got 20 terms. Okay, thanks guys, thanks for watching, and see you next time.